Starting up, guys. I'm getting a black screen. Oh, no, never mind. I'm good.
All right. Want to do a slide transition or?
No, we're good.
Okay. All right. Hello, everybody. I'm Jeremy Druin, and a little bit about myself. I work for a local large transportation logistics company, biggest in the world, doing pen testing, web vulnerability assessment, and other types of security assessment. And also in my copious amounts of spare time, I work on a project called Mutillidae, originally started by Adrian, and keep that active on SourceForge. Do some stuff with the local SSA, and also run the weaponized YouTube channel. So today is going to talk about path relative style sheet injection. This is a type of a cross-site scripting vulnerability. So start with a brief overview of cross-site scripting. And this is a type of attack that occurs on the client side of a web application. So in other words, it's running in the user's browser. And it basically depends on the application not encoding output, so that the browser has a hard time telling the difference between data that was sent into the application and scripts that were injected into the application. Now usually, if you take a script from one website or one source even, and you try to run it in a separate website, there's some protections that are built into the browser itself that will keep the script from interacting with the page. It also protects the cookies and some other resources on the page from being changed by the JavaScript. So an example here is we have google.com/home, not a real page, but certainly a real site. And if you look at the script at the bottom of the screen, it's from the domain of yahoo.com. So if you were to include the yahoo.com script into the Google page, that yahoo.com script would not have access to change the Google page, and also it would be restricted from interacting with the cookies and the other resources that are associated with Google's page. So the same origin policy works on, in theory, 3 parts. One is the scheme, so HTTP or HTTPS, then the domain name, and then finally the port number that the web application is running on. And I say this in theory because some browsers tend to ignore the port, and so you really end up having same origin based on the scheme and the domain. And then of course, since there's only 2 schemes, and a lot of pages will offer the exact same resources in both HTTP and HTTPS, a lot of times it really comes down to the domain name. And the example here, this script would only work on the 5th line down, the one that's bolded, because that's the only one that has the scheme, the domain, and the port all matching. The port's implied as port 80 because it's HTTP, and the port's not otherwise explicitly listed. So with cross-site scripting, the idea is to inject a script into the application, usually via some sort of input parameter. It could also be data that's sitting in a database and you wait for the application to select it, or perhaps in a file and you wait for the application to read it. But in all cases, you're trying to get source code to be incorporated into the web page that the application produces. So the application itself will be serving this malicious script. So we can see in this diagram that a script has been injected via the message parameter that is part of this URL. And so the attacker in this case has injected some mythical evil method and put that inside of script tags. This parameter travels all the way to the server, and then the server's source code reads the value of that parameter and then uses that to create an H1 tag. and it says hello and then the value of whatever the parameter is. So in this case, it looks like they're asking the user to type in maybe their name, and then the application would incorporate the name into the response and say, hello, Fred, or whoever that was. So the script is going to travel all the way back to the browser. And when it finally reaches the browser understands JavaScript and can parse it and execute it. And that's when the attack will actually occur, is when it gets back to the browser. So in this theoretical example, if we pass in a script that can get incorporated into the page, and then the page does not encode that data value, then it's possible for the script to execute. So the confusion is that sometimes developers expect all of these parameters to have data come into them, but there's nothing really restricting someone from putting code into those variables and sending them on their way into the application server. So at the bottom here, this is what the final page would look like after the application got done incorporating the data in, and this is what would reach the user's browser. So in this case, it's syntactically correct. Even though it's not intended, the evil method would execute. So path relative style sheet injection is a type of this cross-site scripting. And typically it's going to be the reflected type, the one that we just described, where the injection occurs on the client, travels all the way to the server, gets incorporated into the page, and then sent back to the client where it finally is able to execute. Now the injection in these cases, rather than being JavaScript, is actually cascading style sheets. I'm sorry? Style sheets would be, yeah, style sheets would be like whether you want to make the font bold or change its colors, very typically. And then there's a pretty rich language that's actually developed in this 3rd edition of CSS where you can do lots of things like cause animations and 3-dimensional objects to spin and stuff like that. So, yep, but it's, so in the browser you basically have an HTML parser that we're all familiar with that parses the tags into a drawing, and then you have the styles that are applied by the browser to format the HTML, and then you have script, usually JavaScript, that can interact with the HTML. So pages are actually made up of lots and lots of different files, and I took a partial picture of just what the Mutillidae homepage looks like. And these are only about half of the files that make up that page. And I highlighted a couple of them. The question mark was about the 10th file or so that was fetched, and the PHP logo was somewhere around 15th or so. And all of those were called upon by the main page, which is highlighted in the red square at the top. So the main page is going to ask for these other resources to be included when the page loads in the browser before it actually has a chance to be parsed. You're going to have images, scripts, and styles typically. So at the bottom here I've got a couple of those included images, the ones that were highlighted, and this is the full path to those images. So to avoid putting multiple copies of the same exact, say, JavaScript or style, developers usually will house those scripts in separate files, and then they will include them into the main page. This has a lot of advantages because if you come up with a nice style sheet and you want to use it on many pages, you can write the style sheet one time and then deploy it to all the different pages just by referencing it when the page loads. And it also has another advantage. Anyone who's been a developer knows that when you make a mistake, it's much better to be able to change or fix the mistake in one file and have it propagate out than to have to go to a bunch of individual web pages and make the same correction over and over again. And in the picture here, this is the global style sheet for the Mutillidae project, or at least the first few lines anyway, that is included into the main page to format all the styles, make the border, menus, everything else look nice. So there's a couple different ways you can include these files. You can have the relative path and the absolute path. And these paths are generally specified by the tags that will include these files. So there's link tags, which are often used to include style sheets. Anchor tags typically will include a reference off to another location. You also have references to JavaScript with the script tag. And there's a couple of examples here. There's a link tag in the middle that is including a reference to the global styles style sheet that we just looked at a second ago. And then down at the bottom is a reference to a JavaScript file called bookmarksite.js. And that's being referenced by the script tag. So with the absolute links, the source code is specifying the full path. And this is pretty uncommon. But in this example, an anchor tag is referencing global styles using the full path, starting with HTTP, going all the way through the server name, the file path, all the way to the resource at the end. The relative link at the bottom only references the difference between the current page and the resource. So since the current page is already at localhost Mutillidae, the relative link is going to just have the difference, which is styles global.css. So now that we see that there's two different kinds of links, we can talk a little more about how the browser figures out what the full absolute path is, given that it only has the relative path. Well, the first thing it needs to do is figure out the base URL. And that's the directory that the main page is in, the page that's calling upon this resource. And then it'll append that relative path that was referenced. And after you add those two together, what you should get is the full path to the resource file, the style sheet in this case. So we're going to make an assumption that we're talking about the Mutillidae project, and we have the path /Mutillidae is the file that the main resource is in. And so we would need to add on the relative path to that to get the full path. The reason the browser behaves this way is it's following the RFCs on what a URI looks like. And URIs are pretty familiar to all of us, but may not think about their construct very much. They basically have the scheme, the HTTPS or HTTP, and then the hierarchy is going to be the essentially the authority. It's the domain for all practical purposes, and the port, and then user credentials, but we don't see those very much in web. And then you get into the absolute path. And the important thing to notice here is just that it starts with a slash and then continues with file directory locations separated by more slashes until you get to the very end. So the browser is going to match the file name located after the last slash. Easy enough. And here we have an example that's been worked. So the browser has taken off the resource name and it's left with the base URL. And then it's going to read the relative reference, in this case in this href tag or href attribute, and it'll append those two together and get the full path to the style sheet. And that works because that is in fact the path to the style sheet in the Mutillidae project. Now if we compare that against how PHP will get the file that the browser asks for, it's a little bit different. So PHP has a configuration inside of Apache, and Apache uses this files match directive to figure out where or which processor should process the file. So we see the files match directive here for PHP files, and they can have lots of different extensions like PHP 3, 4, and 5, or PHP-TML and things like that, but typically we're all used to seeing them as .phps, and that's certainly the standard. So the way that the server is going to fetch the resource that the browser asks for is it's going to see this index.php, which matches that regular expression, and it will invoke the PHP handler to generate that HTML file, and then Apache will return that HTML back to the browser. So notice that there's two different ways that these resources are parsed, and that can create some confusion in certain cases. So in our example, both the browser and the server agreed on which resource was being asked for. In both cases, they came up with index.php. And both of them agree that the path is Mutillidae. So they both calculated the path the same, even though they used two different methods. But since the web server is parsing based on the file extension, what happens if you end up having extra directory after the resource file that PHP is looking for? And so take this path at the top here. We actually have the foo and bar directory specified after the resource index.php. So the browser is just going to go through its normal calculations, and it'll have the word bar will be considered the resource because it's after the last slash, so we cross that out, and now we have our base path again. And then we need to add styles/global_styles.css, that relative path from earlier, onto the end of the base URL. And so we will calculate this URL is what we need to ask for in order to get the global_styles.css from the web server. So the browser is going to ask Apache for this file, but the file doesn't exist. What's the web server going to do? Well, the web server is going to do what it always does, which is it's going to look for the regular expression matching the .php on the end. So what Apache is going to see is it's going to see index.php, and it's not really going to be too concerned about all that stuff that came after index.php. It's effectively going to end up looking for this file here, index.php. So you have a situation where the browser is asking for a style sheet named global_styles.css. Apache ends up asking PHP for the index.php file, which PHP is more than happy to return because that does exist. So the browser wanted a style sheet, but it got back an HTML file. And we can actually see this in this screen capture here. If you look at Inspector on the left, you'll see that the browser is convinced that global_styles.css was fetched because that is, after all, what it had asked for. But if you look at what it was actually returned, the doc type is HTML. This is actually the index.php page that has been returned. So the browser wanted a style sheet, got back an HTML document. Usually this is not a big deal because the browser will look at the type of document that was returned. It can pick up clues like the doc type and the content type that's returned back as part of the HTTP body and the HTTP header, and it can reason that I wanted a style sheet, I got back an HTML document, something's wrong, and it'll just kind of bail out. It won't process the HTML document and pretend like it's a style. So really we're not going to have a problem, except for sometimes. With browser compatibility mode, there may actually be opportunities for the browser to go ahead and parse that HTML document as a style sheet anyway. So browsers want to try to be friendly to pages that are older and more frequently, if we're honest, pages that are not written very well. So we might have pages that are not syntactically correct, but the browser still wants to be able to serve those pages or render those pages as best as it can. And obviously you want to have as much market share as you can, and you want to support as many developers as you can if you're a browser in order to maintain market share. Now, sites themselves can also opt into compatibility mode. So they can declare doc types like the one seen here, the transitional doc type, and try to talk the browser into going into compatibility mode in order to use some older content that may not work strictly in the HTML5 specification, the current specification. Of course, the users themselves can actually set the browser into compatibility mode. I think Internet Explorer even provides a nice little button for you to click to set compatibility mode, and all the browsers pretty much let you go into the options and set compatibility mode. So we go back to the style sheet being asked for, but the HTML file shows up. If the browser is in compatibility mode, it will scan through that HTML document, and it's going to try to find a style that is syntactically correct and use that style to mark up the page that it's drawing. And that's going to let us inject some style into the page. So there's some prerequisites we need. We need the page itself to have a cross-site scripting vulnerability, because we need to figure out a way to inject script, in this case CSS script, into the page and have it incorporated into that page and output back into the browser where the browser can see it. So that's why the path relative style sheet is basically a type of cross-site scripting. Now, JavaScript is the most commonly used script for cross-site scripting. But JavaScript does have some limitations. If the injection is going to land in the middle of HTML instead of landing in the middle of some other JavaScript, you're going to need script tags to break out of the HTML and get the JavaScript engine to execute that script. Otherwise, your JavaScript's just going to land right in the middle of an HTML tag. It doesn't really mean anything to HTML, and so it would just kind of be displayed on the screen. Style sheets, on the other hand, do not require tags in HTML context to invoke the CSS parser. So if you can get a style injected, it can be a little bit easier, since a lot of these defenses that are built into browsers tend to be focused on script tags or other HTML tags to recognize that there's some type of cross-site scripting going on. So here's an example. We have a JavaScript that turns some text red, and we have the equivalent style that also turns the same text red, and these should basically operate the same way. But if you look at the style sheet, you'll see that it doesn't need those script tags in order to operate. And this is going to allow it to pass through filters and other types of kind of naive defenses a lot easier. So it kind of makes this style sheet injection interesting from that point of view. So we can see this with a demo. And I'm going to use the Mutillidae system for this demo. Recently, the path relative style sheet injection vulnerability was added into the project. So now you can download the project and try this for yourself. Our injection is going to have several parts. They all kind of run together. But essentially, we're going to start with a path extension because we want to have some directories after the file name for the reason we talked about earlier. We want to get the browser a little bit confused about what the base URL is. In the orange area, that's the prefix for the attack. The %0A is encoded for the line feed character. And I like the way that the Portswigger blog put that. I think he said something like it gets the page in the mood to accept a style. And effectively, what it does is it's a type of a separator between the end of the path and the beginning of the style sheet. The blue asterisk is called the selector. And in style sheets, a selector is just a declaration of what you want to apply the style to. The asterisk is a special meta character. It means
Sorry about that. I'm Geek here, and Jeremy. We lost the audio from this point on. The demo continues, but not the audio, unfortunately. Do you have anything to say about the last, like, let's say, 10 minutes of your talk, on at least the first section?
It wasn't any good anyway. You didn't miss anything.
But yeah, sorry about this, and hopefully the camera won't crap out on the part 2. Thank you much. Bye.